Hi, so we're going to start in section 1.10 on lines. So we're going to do basically everything you need to know for lines in this section, except for only doing it in 2D instead of 3D. You'll see 3D lines later, but not quite yet. So any 2 points make a line, and so we define the slope of these two as m, or rise over run, or y2 minus y1 over x2 minus x1. If you do y1 minus y2 and x1 minus x2, it ends up being the same. Vertical slopes are undefined, horizontal slopes are 0. So here, if I was going to do this, I'm just going to count units. And so here I'm going to go down 1, 2, 3, 4, 5 units. So I'm down 5 units, and over 2 units would be -5. Oh, hold on. I can't count, can I? Oops. That goes down 6 units because we go all the way down to here and over 2. So it'll be 6 over, so -6 units down, 2 units over. So my rise is -2. So I'm going down 6 and going over 2, right? You could have read this the other way. I could have gone backwards, -2 and up, +6. That'll give you the same answer here, which of course is -3. What is the slope for figure 2, guys? Go ahead and put that in chat. What's the slope of this line? Yeah, so most people are agreeing this is -1/2 because they go down 1 and over 2. Okay. So the reason I put this on here, there's a very good reason I put this on here. This one exists for one reason. The actual slope here is -1. Why? Because notice here that each of the tick marks here are worth 1. Each of the tick marks here are worth 1/2. And so what I'm really doing, this one I do mean to just want you to pay attention. Here I'm going down 1, 2, but I'm moving over 1, 2. So this is -2 over 2. So -1. Pay attention to your scale or your scaling, right? Pay attention to your scaling. This happens a lot in life, right? Where one the axis is a different scale than the other. This will come up in engineering, in politics. This is like, misleading graphs are the #1 thing to use in politics. I don't know why, but they do. So just be very careful when you're reading the graph. So that's the only reason I put this here, is just say hi, be cautious. Okay, so let's go over a couple of these. So here I'm going to do, so we're going to calculate the slope of line given points, and so we're going to call this x1, y1, just to label it, and then we're going to call this x2, y2, and then when I'm done with this page, I am definitely going to save this and throw it away because it's getting crunchy. So here it's y2 minus y1 over x2 minus x1. So if I get down here, so y2 would be 5 minus x1, which would be, or y1, which would be minus a -1 over y2, which is -2 minus 0. So that ends up being 6 because the negatives add up over -2. So this equals 2 minus 3. Here, we'll use the same thing as before. I won't label it this time. We'll use So 4 minus 2 all over negative 2 minus 0. So this is 2 over negative 2. So this equals negative 1. Okay, so that's the end of this page. I'm going to export this one out real quick and close it so my Photoshop's less crunchy. Oh yeah, just put it here. I got to move stuff anyways today. I got to take a drink before I shut it. Hopefully be less lag. All right, so we're going to talk about 3 different forms for a line. We're going to talk about point slope form. We're going to talk about slope intercept form, which one you're most familiar with, and then we'll talk about the general form, or something I know is standard form. I know this is standard form. So let's go over the first one. So this one, the purpose of this is to find equations of a line. So this is for finding equations. Okay. Because with point slope form, given a point or 2 points, you can write an equation of a line. And so the reason this exists is just to help you find equations of a line and just write them out. So here, if I knew a point and a slope, I can just crunch through it. So here it'd be y minus y1, so this would be plus, so plus 1, right? So minus the negative 1 is 1, equal to m, I know is 3, times x minus x1, which is here, which is minus 3. Okay. So here we're going to leave these two as variables. So these two are variables, and these two come from the given point. So this is this, and this is that. Okay, so that's just where you. I see sometimes when I teach this to my 96 students, they kind of don't grab that. So I just like to point it out for everyone, just in case you get confused. So here we're going to do the same thing again. Y minus 2. So here we leave that as a variable. Grab the point equals m, which is minus a half, and then x, leave this as a variable, minus, here we got a 4. Okay. All right, so I'm going to leave that for now. Let's go ahead and do this. So here, if we want to find the equation of a line given these points, we first need to find the slope. So it'll be 4 minus 2. So this minus this over 0 minus 1, which equals 2 over negative 1, which is equal to minus 2. Then here, once we do that, once we know what an m is, we can choose either point. Which point am I going to choose? I'm going to choose this point because it has a 0 in it. Because this will be y minus 4 equals negative 2x minus 0. And we'll find out why that makes all x easier. We'll do the same thing here. M is equal to 2 minus 1. So the y's minus the x's. So minus 2 will be plus 2. So this would be a fourth. I'm going to choose a point. I'm just going to choose this point, or I'll just choose a point. Minus 2 equals 1/4 x minus 2. Okay, and so here we've written the equation for lines. So slope-intercept form. So here we're going to write slope-intercept form is, this is the best for graphing, right? This is really easy for graphing. It also is easy, so it's good for graphing and it's good for solving 4 points. And what do I mean by that? If I know 1 point, can I get the other one? Yeah, this is really easy. So if I know x, it's easy to figure out what y is. This is a little bit more complicated to solve for points, right? And if I know what y is, it's kind of easy to solve for x. So we're going to write all these examples in point slope-intercept form. So I'm going to just write C above, and we're going to go back up and finish, move it to slope-intercept form. Most of the time in math classes and in your engineering classes, they're going to want you to put it into this form just because that's the most common form. So let's go up and do that. So here, if I move over the 3, I will get 1, or if I distribute the 3, I get 3x minus 9. Move over the 1, and I'll get y equals 3x minus 10. Here, if I move over the half, distribute the half, I'll have 1/2 x plus, in this case, 2. And then if I move over the 2, I'll get y equals minus 1/2 x plus 4. Here, if I distribute the negative 2, it really doesn't matter, so I'll just go ahead and go for it. So this is minus 2x, move over the 4, because there's a 0 here. Here, this one we'll do in 2 steps, will be minus 2 equals 1/4 x minus 1/2. And so this is y equals 1/4 x plus, so plus 2, so negative half plus 2, so this would be, so what I'd really move over would be 4/2 plus 4/2. So here, so 4/2 is 2. But if I move over 4/2, so 4 minus the 1 is 3/2. Okay. All right. I'll leave that one out. I'll go ahead and export this one as well. And go ahead and close this out just so it doesn't get crunchy. And then we'll go ahead and do this. All right. Let's talk about some special lines. So here, the graph of a horizontal line is y equals b. The y-intercept is b and the slope is 0. So a horizontal line just kind of goes. So a graph of a vertical line is x equals a, with the x-intercept of a0, and the slope is undefined because it's just has technically infinite slope in some way, is one way of saying it. Even though it's not technically infinitely, it's just a way of saying it. So here, if we want to find the slope of this line, notice that even if I didn't recognize, because how you recognize a vertical or horizontal line, if they have a repeated either x value, so this is a repeated x value, so I know this is a vertical line, and if I have a repeated y value, I know this is a horizontal line. But let's pretend we didn't know that right off the bat. Well, we just, 4 minus 2 over 1 minus 1 equals 2/0. Well, this is undefined. Undefined. So once I see that, I know it's this. And so what's true about this? Well, it's s equal to a. What's the a? Well, it's the repeated x value. So this is just x equal to 1. And if I was going to graph that, I just say here's my graph. Just right here at 1. Here at 1, right? This is my x equal 1 line. Here, if I did this, not pretending I didn't know it was a horizontal line already, I'd have 1 minus 1 over 2 plus 2. So this would be 0/4. So this is equal to 0. Once you see that's a 0, you just say y equals 1. Whatever that repeated value is. And if I just graph this one, this would be my line. Let me draw my lines in a different color. So you see, there we go. This is y equals 1. So it's just a nice flat line. Okay, so when you see these, just be aware of them. The process is 0 different. You'll calculate m first, and if m is undefined, it's horizontal, grab the x. If it's 0, it's no. If Since undefined is vertical, grab the x. And if it's 0, it's horizontal, grab the y. All right, so this is called the standard form or general form. I've seen these used interchangeably, where you have x plus y plus b equals c equals 0. This one actually I wrote is for. This one's useful for finding intercepts because your intercepts are kind of given to you. Sometimes you'll see the c here, sometimes you'll see the c over here. It just depends on what they're talking about and who wrote the book. So here we want to sketch the graph and find the intercepts. So how do we find the intercepts? Well, here these are lines. This is really so the x intercept, we're going to set y equal to 0. If I set y equal to 0 in this equation, I just have 4x plus 8 is equal to 0. That means x is equal to minus 2, or the 0, 2 is negative 2. 0 is my x-intercept. So here we'll just go. Okay. All right, then I want to find my y-intercept. So the y-intercept is where x is equal to 0. So here, this is 0. I just have minus 2 plus 8 is equal to that. That means y was 4, or the point was 0, 4. X was 0, y is 4. There's our point. 1, 2, 3, 4. And then we can just see how well I can do. That's good enough. Okay. And most of this you can do in your head. Here, if I wanted to, let's just pretend I want to do this in my head. If I wanted to find one of the points, I just forget about this, right? And say, well, that's 4, so 0, 4. And then I'd forget, and then I'd go, okay, let's forget about the y. That's negative 2, so it'd be negative 2 that, and then you just graph the line. And so this gives you, not only you graph the line, but you know your two intercepts, and intercepts are very useful information, depending on what you're doing, right? Let's pretend we had, like a ball bouncing or something. The x-intercepts is where the ball's on the ground, stuff like that. So you'll use intercepts a lot. All right, so we're going to do the same thing here, just we're going to kind of do it in our heads this time. So x-intercept. So the x-intercept is where y is 0. So if I did that in my head, I need this. I need 2x minus 12 to equal to 0. So that means I get the point. Well, that means this x better than 6. It would be 6, 0. And if I wanted to write that out, this is y equal to 0, right? That gives me 2x minus 12 equal to 0. That means x is equal to 0, or equal to 6. And that's, so I'm going to write out what I'm doing in my head, but you can, in truth, you should be able to, using this form, kind of crunch through things in your head. So that means x is equal to 0. Means I have minus 3y minus 12 equal to 0. That means y equaled minus 4. So 0, comma, negative 4. So here is 0, 6. So 1, 2, 3, 4, 5, 6. And then 4. 1, 2, 3, 4. There we go. So I should have counted this way. 1, 2, 3, 4. I know this is an 8 by, there's 8 tick marks each way because I programmed it to be that way. So, hi, I missed my points. Yeah, it's a little better. Okay. All right. I'll let you guys copy this one down. Let's go to the next page. All right, so we're going to talk about parallel and perpendicular lines. So if you were taking this class at UNLV for credit, I would probably harp on this really, really hard because they just love answering these questions. They just love, love, love it. Because if you can find a line, um, if you can find a line that's parallel or perpendicular to this line, you could do everything before that. So it just kind of encapsulates all the thoughts. So parallel lines, we use this symbol. Perpendicular lines use this symbol. I will be using these symbols, right? So parallel and perpendicular. So two lines are parallel if and only if they have the same slope. Um, that's true. Two lines are perpendicular if and only if the product of slope is -1. This is the way your book worded it. That's not entirely true. If and only if means um, if the product of the slopes is -1, yes, it's perpendicular, right? But if it's perpendicular, the product of the slopes may not be -1. And the one that breaks this real quick is the and I want it is the product of slopes of -1, or one slope is undefined, and the other is 0. AKA a horizontal line is perpendicular to a vertical line, and a vertical lines. So we need to add that. The book leaves it out. I don't know why. All right, so let's determine if the paired lines are parallel or perpendicular. It just helps to number our lines. So even if the book does not, you should just give numbers to your lines. All right, so the slope of line 1. The slope of line 1, here we're just going to pick some point. I'm going to go from here. It's over 1 and then up 2, so that's 2 over 1. So 2. Here we're over 1 and up 2. So this is also 2. So this is parallel. Here, let's go from this point to this point. So I'm going to go over 2, up 1. So that's 1 over 2. And then here, let's go from, I don't know, this point to this point. It's nice to define points. So I'm going down 2 over 1. And so that'd be -2, the product of these slopes. So -½ times -2 is equal to -1. So this is indeed perpendicular. Now these, they look almost perpendicular, but if we actually tested this, this is over 1 up 3, so the slope of line 1 is 3. This is just over 1 down 1, so this is just -1. So this is neither. In fact, if you took two random lines, most likely they're neither perpendicular or parallel. So most lines are not these special cases. All right, so what are we going to do with all this? We're going to find, let's start with B, and we'll go back to A. So we're going to find, find the equation of a line of find the equation of the lines given a point. So they go through this point that is both parallel and perpendicular to the given line. So here I'm giving you a line. And so the first thing to do is I need to find the slope of that line. Okay. So the slope of this line, we're gonna just put it into slope-intercept form. So it'll be 2x plus 7. We're going to divide out by the 4. And so we'll get 1/2 x plus 7/4. What do we care about? We only care about this. So the slope of the given line is aha. Therefore, if we want to find the parallel and the perpendicular, we'll go ahead and kind of box that off. M here needs to be the same if for the perpendicular parallel line. M here will be the opposite reciprocal. So here we're going to take, so this will be -2/1. So you just, here, does everyone know what I mean when I say opposite reciprocal for finding the parallel? Anyone confused on that whatsoever? You can send me a direct message in chat if you are. If not, yeah, I'm confused on what that is. Or yeah, you understand. Yes, I'm confused. Okay, so opposite reciprocal. Okay, yeah. So let me do that right here. So opposite reciprocal. So the reciprocal, so we're going to take our half, right? So let's do the reciprocal first. So the reciprocal of a fraction is flipping it. Basically flip it. So it would be 1/2. And just a bunch of other examples, which I'll write. So the reciprocal of 4/7 would be 7/4. The reciprocal of 3 would be 1/3, because you can write 3/1 technically. The reciprocal of 7/2 would be 2/7. And so the reciprocal is just whatever the fraction is, you flip the top and the bottom. So the numerator becomes denominator, and denominator is going to be. Then the opposite part is you take the negative of that. And so here I get 2. So this ends up being -2. And so in order to get to this equal to -2, we take the opposite reciprocal. And the reason is, let's take 4/7 and I multiply it by 7/4. So if I multiply by the reciprocal, I get 28/28, right? So 28/28 is indeed 1. And so multiplying by a reciprocal always gives you the 1. But what do we want the perpendicular line to be? -1. So we take the opposite reciprocal, so we get -1. So here, my slope was 3. The opposite reciprocal will be -1/3. I multiply that across, I get -3/3, which gives me -1. So that's how you always find that. Okay. All right. So I need, I wrote this all on the wrong layer, of course. But I'm going to need some room for that. So I'm going to go ahead and just clear that out, just so I have room. So that's how you find opposite reciprocal. Oops. Yeah, that's fine. So these are all reciprocals. Okay. So now that we know reciprocals, we'll go ahead and do so we have our point that we want to go through. So it'll be y-1. Our slope in this case is 1/2 of x minus 2. Here, be y-1, and our slope here is -2. So x minus 2. All right. And since we have time, let's go ahead and convert that over. So this will be -1/2 minus 1. This will be x equals 1/2. Sorry, I forgot my x there for a second. Here, we'll have y-1 equals -2x plus 4. Moved over the -1, we'll have y minus 2x plus y. Okay. Okay, so that's how you find the parallel and perpendicular line. So you're going to take the given line, whatever it is, find its slope. Once it's slope for the parallel line, you just copy over the slope. For the perpendicular line, you're going to take this opposite reciprocal, and then you're going to use the given point and calculate it out. Now here, this is a vertical line, right? No, this is a horizontal line. Sorry, this is a horizontal line. So the parallel, so the slope of this line is 0. So m of this slope is 0. So here, I want my m to be 0, and I want to go through this point. them, so it would be y equals to 2. Because for fm0, we just take the y component. For the perpendicular, I want m to be undefined. And so that will give me the horizontal line. This will be x equal to 1. And so if you have to do parallel perpendicular of a horizontal line, the parallel will be the other horizontal line. The horizontal line that goes through this point, well, that means I need to go through 2. And then the perpendicular line would be the vertical line that goes through that point. That means x equals to 1. Now, if this was a vertical line, the parallel would be the vertical line, and the perpendicular would be the horizontal line. Okay. All right. Oops, let me leave that up for 1 second. All right, so when would we use this? What's it? M undefined. Or this says M, actually this says MUNDF. That's just one way of abbreviating undefined. Sorry. If my handwriting's ever unclear to you, by all means, let me know. And the parallel symbol, that's M equal to 0. Sorry. If my handwriting is ever unclear, please let me know. All right. All right, so let's just do this last problem real quick. All right, so here I want to show that this forms a right triangle. And so I'm just going to label these as points. I'm going to call this P, Q, and R. Just the little column points, right? All right, so here, I'm going to start here, and I'm going to just graph this real quick. So here's P, so over 3 up, so that's B. Let's do R next. So 1, 2, 3. So is that 3? So 4, 5, 6, 9, 10, 11. I count right? Let me count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. I'm going to go up 5. 1, 2, 3, 4, 5. So right here, this will be my R. And then here at 8, so 3, 4, 5, 6, 7, 8. And I'm going to go up 17. 11, 12, 13, 14, 15, 16, 17. I'll count that one more time. 1, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16, 17. Run this in. So how do I know? So show that these points form a right triangle. Right, this is Q. Okay, so in order to do that, we're going to assume that this is probably the right angle here, right? This one doesn't look like the right angle. This one doesn't look right angle. So how do we do that? We're going to have to show the line segment PR, oops, PR is perpendicular to the QR line segment. So QR and PR are perpendicular. So we just want to find the slope of these two. Oops. All right, so the slope of PR, let me zoom out just a little bit. So P, so we're going to go from R to P, so it will be 5 minus 3. So this will be 5 minus 3 over 11 minus 3. That gives me 2/8 or 1/4. Okay. And then from here, the QR slope. So this would be, let's go from, let's just use from R to Q. Let's just do the same thing. So here we'll go from 5 minus 17 over 11 minus 8. 5 minus 17 will give me minus 12. 11 minus 8 will give me 3. So that gives me minus 4. So 1/4 times negative 4 indeed equals 1. Therefore, these three little dots mean therefore. Okay, you'll see that sometimes in math. Therefore, the line segment PR is perpendicular to QR. So 90 degrees. So if it's perpendicular, it's also 90. That means it's 90 degrees. And if that's 90 degrees, that makes this a right triangle. Okay. And sometimes you put a little box. Sometimes you put QED. You don't need to put this stuff in any of my classes because we're not doing any formal proofs ever.